Welcome everyone to week 6 of the Azure Cert Prep course. Today, everyone, we will be talking about Cosmos databases. Now, while these slides are very minimal, there's only about 20 of them, these are pretty dense slides. So I really encourage you to pause the video often, take notes if you need to, because we're really going to talk about a lot of different APIs, that is application programming interfaces, that can exist within the Cosmos database architecture. So we've gone over relational databases. We've gone over OLTP solutions. We've gone over some abstract OLAP solutions. And we've also talked about binary objects as well as file stores last week. This week, we're going to pivot, and we're instead going to focus solely on NoSQL solutions in Azure. So once again, everyone, DP-900 is a pretty broad overview of every single Azure technology. So really, we're just trying to learn terminology and understand proper use cases for different services. As we talk about these services, try to think of cases where you might want to apply this type of service, right? So we talked about SQL, we talked about binary objects. When would you want a SQL solution, and when would you want a solution that handles binary large objects? Think about how these could apply to not just business cases, but your everyday life, right? Like if you're storing some sort of data for some sort of project or some sort of effort that you're trying to lead, when would you use one specific type of database versus another? As we keep moving forward in this course, and also as we conclude this course, hopefully I'll be able to provide you all more discrete examples of when you might want to use one service over another. So, yep, like I said, today is going to be a review of the Cosmos database on Azure. But before we get into that, let's actually go over some review. So I don't expect you to be able to answer every single one of these questions, but these are actual DP-900 questions, so that these are great practice for you to use. So here we have Azure Blob Storage. Which one of these data types do you think fits the Azure Blob Storage or fits into Azure Blob Storage? Take a moment, pause the video, and consider if you either want to place image files, key value pairs, or relationships between employees within this data type section for Azure Blob Storage. All right, hopefully you paused the video and hopefully you've chosen image files. So always keep that in mind. Common media, such as images or videos, that always goes within Azure Blob Storage when it comes to the DP-900 exam. I don't expect you to know this yet, so we'll skip over this. Let's go over to Azure Table Storage. All right, so if you were, which data type, excluding image files, fits into the Azure Table Storage service? Is it key value pairs or relationships between employees? Pause the video, look back to your slides if you need to. All right, so hopefully you chose key value pairs. So keep that in mind, everyone. Whenever we talk about Azure Table Storage, that strictly has to do with simple key value associations that you want to store for super quick access, something like a cache or something like that. We're not talking about these large transactional databases with many columns. We just simply have a key and we simply have a value. And now through the process of elimination, you should also be able to figure out that the relationships between employees goes within Azure Cosmos Database Gremlin API. And we'll talk about that later today. All right. Next question, or next series of questions. You can use blob, table, and file storage in the same Azure storage account. True or false? Pause the video, think about this. The answer is most definitely yes. Next question, you implement Azure Data Lake Storage by creating an Azure storage account. Now let's think about this as well. True or false? Feel free to pause the video. All right, so hopefully you also chose true for that as well. one thing to keep in mind is that when you want to create Azure Data Lake Storage, the first thing that you always need to create is a blob container, and blob containers always go underneath Azure storage accounts. So that's just something to keep in the back of your mind as you think about blob containers in Azure. In order to create a blob container, you need to create an Azure storage account. So therefore, if you want to create an Azure Data Lake Storage, you need to create a blob container, which also necessitates that you need the storage account as well. Cool. All right. Yeah, let's talk about normalization as well. So question 1, normalization involves eliminating relationships between database tables, true or false? The answer is no. You are definitely not eliminating relationships between tables. In fact, you're actually creating relationships sometimes. All right. Question 2, normalization. Normalizing a database reduces data redundancy, true or false? Yes, that is true. Yes, you reduce redundancy. Question 3, normalization improves data integrity. Well, if it reduces data redundancy, then by logic, it also has to improve data integrity. Keep that in mind. These two are opposing forces. The more data integrity you have, the less data redundancy you have. That's always how it works. Cool. All right. Let's see here. Yeah, why don't we take a look at this as well? A blank is an object associated with a table that sorts and stores the data rows in the table based on their key values. What do you think? Is this a clustered index, a file table, a foreign key, or a stored procedure? I'll give you all a hint. We're looking for a specific database object that makes data access faster in a relational database. And with that hint, you hopefully chose a clustered index. So keep that in mind. When you create a clustered index, you are associating it with a table, and it basically allows efficient querying and storing of rows in a table based on key values. All right, let's keep moving forward. Skip through this. And yeah, why don't we take a look at this question as well? Once again, these are all real Azure DP-900 questions, so this is good practice. If you're getting any of these questions wrong, please feel free to look back at the appropriate videos to kind of remind yourself about these concepts, or feel free to just directly ask me questions over Slack. Next question, which Azure storage solution provides native support for POSIX compliant access control lists? Is it A, table storage, B, data lake storage, C, queue storage, or D, files? All right, so this one's a little tough, but I'm just going to remind you that ACLs, access control lists, and these are strictly made for folders on your computer if you have a Linux system. So hopefully this hint will lead you to the correct answer. If ACLs are for folders, and the only way, and I want you to look through this list of resources, and I want you to think, all right, what is the only resource here that allows me to create folders in Azure? The answer is data lake storage. So keep that in mind, everyone. If you want to create POSIX compliant folders in Azure, data lake storage is your solution. All of this other stuff, this has to do with nothing. None of this has to do with POSIX compliant access control lists. All right. Now that we've gone over that review, let's dive into Azure Cosmos database. So just like I mentioned early on, we talked about relational databases, we talked about blob containers, we talked about Azure file storage. Now we're going to talk about non-relational data storage, or rather, not just SQL data storage, aka NoSQL data storage in Azure. So non-relational databases, some non-relational databases that we can have in Azure through the Cosmos database system includes key value stores, column family stores, graph stores, and finally, document stores. One thing to keep in mind is that Cosmos is not just a non-relational database. It could actually have Postgres, or rather, you could create a Postgres. You could create an instance of a Postgres database through Cosmos databases. And there is a specific reason why you'd want to do that. But most notably, Cosmos databases are specifically known for their NoSQL solutions. Let's talk about some of these, and let's talk about the specific API that comes along with these NoSQL solutions. All right. Well, actually, before we get into that, let's just talk about the general reasoning why you might want to use Cosmos. So Cosmos essentially provides super fast read and write performance for massive volumes of data. We're talking about terabytes of data, maybe even petabytes of data. I think Xbox actually is hosted over Cosmos database or an instance of Cosmos database. Can't confirm that, so don't take my word for it. But anyways, we often use Cosmos databases for Internet of Things and telemetrics, retail and marketing, gaming, and web and mobile applications. And the reason that we use the Cosmos database for these high volume systems is due to something called automatic indices as well as database partitioning. We'll talk about what database partitioning is later on when we get to Postgres, but for now, let's just go back to our classic NoSQL solutions on Cosmos. So first up, let's talk about document databases in Azure Cosmos DB. So document databases are essentially, and we might have actually talked about this early on in the course, is a JSON file. So if you need to store some semi-structured data, we're not talking about rows and columns here, we're talking about data that could come in many different formats, Azure Cosmos DB is your solution. So keep that in mind. Document databases go inside of Azure Cosmos DB. And in fact, we actually use the SQL syntax to interact with potential document databases. And that makes it super convenient, right? Because it doesn't matter how the database looks like under the hood. As long as you know SQL, you're essentially able to pull any sort of data that you want from this non-relational database. Hence why knowing SQL is always a good idea. You'll probably find many other implementations of SQL just like this that are not just designed for relational databases. All right, so that's right there is document databases. And document databases, and you might be thinking like, why would we want document databases if relational databases exist, right? Well, one common analogy that people pull up is the Amazon shopping cart, right? An Amazon shopping cart could look very different across different users, right? The number of items that someone's purchasing, the characteristics that this item has, and considering they might not even purchase this item. They might actually just delete this item altogether by the end of their session. So in that case, document databases are actually a really, really good idea because they come in this sort of semi-structured format. If you were to try to coerce all that information into a relational database that's perfectly structured and has specific columns that we need to hit, you're probably going to have a lot of null values, or worst of all, you won't be able to reflect every single type of object, which really goes against the whole purpose of having a database at the end of the day, right? So that right there was the document databases API for Cosmos DB. Next up, everyone, we have MongoDB for Cosmos DB. You might have heard of MongoDB before. It's actually another document database, nothing too special. The only thing, however, is that instead of using SQL, we use object-oriented syntax to query our data. So as you can see in this example, this programmer types in db.products.find ID123, and this pulls up this chunk of data right here. We're not using SQL syntax. Instead, we're actually using the JavaScript syntax. It doesn't have to be JavaScript. It could actually be Python or Java, or some other programming language. But this just goes to show that we cannot interact with MongoDB using the SQL API. All right. Next up after that, everyone, once again, I mentioned that Cosmos DB is not just for NoSQL solutions. It's actually also for relational solutions such as Postgres. Now, once again, if you're just trying to store a little bit of non-high volume data, maybe even for analytical purposes, Cosmos DB is probably not going to be your best bet. We use Cosmos DB when we need to store high volumes of data, and we need super efficient read and writes in order to pull and write data super quickly, something for like gaming and stuff like that. The only reason we might want to use PostgreSQL in Cosmos DB is due to the fact that it supports something called automatic database sharding, which essentially allows us to scale our data greatly for less cost. All right, so now that we've just breezed over that, let's go back into NoSQL solutions. Another solution that we have is Cosmos DB for tables. And this is essentially when we have key value tables, super similar to Azure Table Storage. Once again, we do not use the SQL API to interact with this data. Instead, we use something like a URL service endpoint to retrieve the data. Notice that we have HTTPS, endpoint, the name of the table, the partition key, and the row key. And this right here will give us the specific partition and row that we are looking for from Azure Table. Once again, super similar to relational databases, but not as complex, and also a lot cheaper. And this is just a rehash of what Azure Table Storage looks like in Azure, or what tables look like in Azure. Feel free to look at the previous video if you want to get a deeper in-depth look. Next up, everyone, we have Cosmos DB for Apache Cassandra. So Apache Cassandra is an open source database for something called column family storage. Once again, this is quite similar to relational database. However, not every row needs to have the same column. And that might seem like an odd statement, but hopefully the illustration in the next slide will reveal what I mean. And the cool thing about this is that we actually use SQL syntax. So notice what's going on here. Most of the APIs that we've talked about really sometimes don't use SQL. However, a good chunk of the APIs also do use SQL. So for example, NoSQL in Cosmos DB, that uses SQL. Postgres for Cosmos DB, that obviously uses SQL. Apache Cassandra for Cosmos DB, that also uses SQL. However, you do have a few services and APIs that do not support SQL, which is important to remember. Now, let's go back to talking about column families in Cosmos DB, or rather in Apache Cassandra. So a column family table stores data in rows and columns, just like a relational database would. However, it is highly denormalized, and we denormalize this table in order to model super sparse data. And when we say sparse data, we basically are stating that there are going to be a lot of missing values. And instead of trying to keep track of all those missing values, we basically compress all of our data into this sort of hierarchical column structure. So here's an example of what a column family database looks like. As you can see, we have customer ID, and we might even share the same customer ID across rows. However, when it comes to the specific column family, we have some things called identity, and then we have some things called contact info. And notice that across these column families, we don't always reflect the same information. For example, in the first row, we do not have a suffix or title. However, these bottom two rows, they alternate between suffix and title, which is obviously quite different from one another. Furthermore, here we have phone number. Occasionally, we don't have phone number. So whenever you're getting volatile data that varies in structure like this, column family databases are a pretty good idea. You probably don't want to coerce this or force this into a relational database, because once again, you're going to get a lot of missing values. All right. And lastly, we have something called Apache Gremlin. Now, we use Apache Gremlin for something called a graph database. And instead of modeling entities and events in um, rows, we instead model them in this mathematical structure called a graph. Now, a graph is essentially just a structure with nodes and these things called vertices or edges. You've probably seen a graph in your lifetime, actually a whole bunch of times, especially within this fellowship. But yeah, this is essentially what a graph is. And this is actually really useful for modeling certain types of relationships. Think about it like this. If you want to keep track of information about internet routers in your business, maybe a table won't be the best idea, because not only do you need to keep track of the information of the entity itself, but you also need to keep track of what this entity is connected to, right? And I'm no internet or network person, so maybe I'm making a huge mistake when I say this, but we kind of can think of routers as being connected to one another, right? Like here's router 1, here's router 2, here's router 3. So a graph database would be a really good idea to model these relationships, because not only can you keep track of the specific details of each router, like for example, the year it was installed, I don't know, the color, but you can also keep track of who it's connected to. So router 1 is connected to router 2, which is connected to router 3. There are many different types of graph databases out in the world, especially these days with the rise of ChatGPT or generative AI. However, for Cosmos DB, we have Apache Gremlin. And in order to interact with Apache Gremlin, we must use the object-oriented syntax to traverse the graph. So once again, we're not using any SQL. Instead, we're using some sort of specific programming language to manipulate and pull information from the graph structure. All right. Yeah, and this is just basically a rehash of what I just said. Graph databases are good for storing data that requires relationship-based queries. All right, so that's it for Cosmos DB. In the next video, we'll talk about OLAP, and then we'll go into the practice exam. See you then.